Hello friends, I welcome you to my YouTube channel MacPM. In this video, we will try to find out the force exerted by this jet, which is striking tangentially this symmetrical plate, uh, and this jet is making an angle theta from the horizontal. And we are assuming that this plate is smooth, or there is no friction loss along this plate. So the velocity with which jet is striking at one end will be same as the velocity which is with which jet is exiting this plate. So after calculating these forces, we will try to find out the forces also on the unsymmetrical plate. So it is symmetrical plate means the angle theta here and at inlet and outlet angle theta is same. So let's find out the force is equal to rate of change of momentum, which will be equal to initial momentum minus final momentum divided by time. This is rate of change of momentum. So it will be equal to momentum is mass into velocity, m into v1 minus m into v2 divided by t, because mass flow rate is constant, so m1 and m2 will be same, so it will be m by t v1 minus v2. M by t is mass flow rate, this m is mass, and this m by t is mass flow rate. So we can write m dot to the mass flow rate v1 minus v2, and here mass flow rate will be density, which is rho, into area of this jet into velocity of this jet, because you can say that mass is rho, matlab density into volume. So area into mass flow rate is area into velocity is volume per unit time. This is area into velocity is volume flow rate per unit time, and this if we multiply it by density, then it is mass flow rate per unit time. So we can write it is as F is rho AV in bracket V1 minus V2. So this is the formula for the force. Now we have to find Fx, or horizontal force exerted by this jet on this symmetrical plate. So it will be rho AV. What will be V1? V1 is the, we can write it as V1x minus V2x. So Fx is rho AV. What is V1x? Velocity in x direction at inlet. So what will be the velocity at x direction at inlet? Say this is inlet velocity v, and this is making an angle theta from the horizontal. So inlet velocity at inlet will be v cos theta. So it will become v cos theta minus, what is the v2x? V2x is velocity at outlet in horizontal direction. So it is v cos theta here too, but it is in opposite direction. So it will become minus v cos theta. It is in opposite direction, so we are writing minus sign. So it will become rho AV v cos theta plus v cos theta, minus will become plus, so 2v cos theta. So it will become 2 rho AV cos theta. Sorry, this v into v will become 2 rho AV square cos theta. So this is the force exerted by this jet in horizontal direction. Now we have to find the force exerted in vertical direction. So we can find out that, so Fy will become rho AV V1y minus V2y, which will become equal to rho AV in bracket. What is V1y? The velocity along y direction at inlet, which is v sin theta. V sin theta minus what is v2y? It is also v sin theta. You can see that v sin theta minus v sin theta is 0. So rho AV into 0 will equal to 0. So force exerted in x direction is 2 rho AV square cos theta, and force exerted in y direction will be equal to 0 because this plate is symmetrical. Now suppose that this plate was unsymmetrical like this, and this angle is theta, and the angle with which this jet is exiting the plate is phi from the horizontal. This is v, this is v, so it will become v cos phi, and this will become v sin phi, and this will become v cos theta, and this will become v sin theta. So if we have to calculate the force exerted along x direction and y direction, then from the same formula it will become fx on, this is unsymmetrical plate because angle is different, so fx will become rho AV v1x minus v2x, which will be equal to rho AV. v1x is velocity at inlet in x direction, which is equal to v cos theta, and v2x is velocity in x direction at outlet, which is in negative direction, so it will be minus v cos phi. So it will become equal to rho AV v cos theta plus v cos phi. We can take out v common, rho AV square cos theta plus cos phi. So this will be the force exerted along x direction by a jet which is tracking tangentially on an unsymmetrical plate. So this is Fx. Now we can find the force exerted along y direction. So Fy will be rho AV v1y minus v2y. It will be equal to rho AV. What is velocity at inlet in y direction is equal to v sin theta, minus what is velocity at outlet in vertical direction, it is v sin phi. They are in same direction, so we have not taken negative, unlike these two are in opposite direction. So it will be equal to rho AV. We can take out v common, rho AV square sin theta minus sin phi. So this will become force in y direction. So you can see that this is not 0. So force will be 0 only if this plate is symmetrical, in like in first case. Here the force in y direction will be also exerted on this plate. I hope you understood how to find out the forces if a jet is striking a plate from a tangential direction. If you understood that, then please subscribe to my channel, and thanks for watching my video.